Hey guys, welcome back to the Chem Nerds Cooking Show.
Have you ever struggled figuring out the amount of ingredients you need to feed a large party?
Have you ever tried using stoichiometry to make your life easier?
Well, we are going to demonstrate how you can incorporate stoichiometry to find the perfect ratio of the ingredients you need to get the amount of products necessary.
Today, we are going to make meringues as an example of how you can incorporate stoichiometry in the kitchen.
The ingredients we will be using are 3 egg whites, 1 cup of sugar, and 1 tablespoon of vanilla extract.
Pause!
What?
Arissa, shouldn't we use the same measurements? How about we use tablespoon?
Great idea, Cindy! Now we are preheating the oven.
Now we are separating the egg whites from the egg yolks.
Next step, whip up the egg whites.
Now we add the sugar while the egg whites are mixing.
Now that all the moles are combined, it's ready to put through the catalyst.
To set up our equation, we are changing our ingredients into symbols. For example, sugar is Sg, egg white is Et, and vanilla extract is Ve.
This is how we set up our equation. So the coefficients in this photo represent the tablespoon measurement and the number of moles of the following ingredients. So we have 16 moles of Sg reacting with 6 moles of Et and 1 mole of Ve. After coming in contact with heat, aka the catalyst, which is represented by the triangle above the arrow, a synthesis reaction occurred. Our product is 1 Sg, 16 Et6 Ve.
Thank God our equation is balanced. Our outcome is that one batch produces 30 meringues, which is represented by the 1 coefficient in front of all the ingredients, which is 1 compound of sugar, egg whites, and vanilla extract.
Since 30 meringues is not enough and everyone wants 2 meringues each, we need to double the recipe and make 60. Now we need to figure out the ratios of each ingredient to double the recipe. Here's a possible scenario of what would happen if you mess up the ratio.
For example, if you mess up the ratio of the sugar to the rest of the ingredients, your meringues will come out less sweet and the mixture won't come to peaks.
One batch makes 30 meringues and we are serving 2 meringues per person, so we need to double the recipe to make 60.
In order to fix this, we use a mole ratio by drawing out the T-chart and double the ingredients.
To figure out the ratio of sugar, we put 2 batches for the given because we know 2 batches will make 60 meringues and serve 2 per person. Then for our what we don't want, we put 1 batch because we know 1 batch won't be enough to serve 2 per person because it makes 30. Then we put 16 tablespoons of sugar in the what I want because we're trying to double the amount of sugar and find the accurate ratio of sugar to the rest of the ingredients. Since the unit batches cancel out, you do 2 times 16, which equals 32 tablespoons of sugar.
We repeat this process with egg whites and vanilla extract so we can ensure that we don't mess up the ratio of other ingredients. Okay.
For this one, the unit of batches cancels out, so you do 2 times 6, which is 12 tablespoons of egg whites. This is the same as the previous ones. The unit of batches cancels out, so you do 2 times 1, which is 2 tablespoons of vanilla extract. This is if you use the mole ratio accurately. If you don't use the mole ratio properly, it can alter the recipe. So now we have the correct amount of ingredients to double the recipe and make 60 meringues. We have 32 tablespoons of sugar, 12 tablespoons of egg whites, and 2 tablespoons of vanilla extract. Now this is enough to feed 30. Yay! For our limiting reactant, we came up with a scenario. So we have 12 tablespoons of egg whites prepared, but my cat knocked over 6 tablespoons of it, so we only have 6 tablespoons left. Therefore, it would only make 30 meringues.
This is our limiting reactant because we don't have enough egg whites for our recipe, and it is limiting the number of batches we can make for 60 meringues. This messes up the proportion of the egg whites to the rest of the ingredients, which makes the batter less fluffy and less of it.
A way to fix this problem is to use stoichiometry. We draw the T-chart and in the given we put 6 tablespoons of egg whites because we only have this amount. Then in our what we want, we put 1 batch because we need to see how many batches of meringues we can make with 6 tablespoons of egg whites. Lastly, for what we don't want, we put 6 tablespoons of egg whites because the ratio is 6 tablespoons to 1 batch.
For the other ingredients, we have to split the amount in half to have the right ratio of the ingredients to make one batch. Limiting reactant can cause a recipe to not always be proportioned accurately to the amount of people who are present. In our scenario, the batch is only able to produce 30 meringues and all 30 people want 2 meringues each, so it's not enough.
A way to solve this problem is to double the recipe to make 60 meringues so each person can get 2 meringues. Stoichiometry can help because it helps us predict the theoretical yield/outcome of meringues we are going to make. It helps us determine the expected outcome of the meringues prepared.
What are the problems that come with baking for a large group?
Well, the recipe is not always proportioned out correctly to the amount of people who are present.
That's so right, and in our case, the problem was the batch was only able to produce 30 meringues, and all 30 people want 2 meringues, so that's not enough.
These are our 30 people.
So our solution is that we double the recipe to make 60 meringues so that each person can get 2 meringues each.
Yeah, that's correct. Stoichiometry can help us because it helps us predict the theoretical yield/outcome of the meringues we are going to make. It helps us determine the expected outcome of the meringues prepared. Oh, to everyone watching, make sure you're aware about the theoretical, actual, and percent yield.
Oh yeah, for our meringues, our theoretical yield was making 60 meringues out of 2 batches. Our goal was to double the recipe for a batch that makes 30 meringues.
Yep, after performing our recipe, our actual yield was 30 meringues because my cat knocked it over. The percent yield is 50%. We figured out the percent yield by dividing the actual yield by the theoretical yield and multiplying that by 100. What may have caused there to be a difference in the actual yield and the theoretical yield?
Well, one issue might be the size of the meringues wasn't uniform. If the meringues are bigger, then there are less meringues, and if the meringues are smaller, there are more of them.
That's so true. Another issue is that the problem of overmixing or undermixing the batter. Undermixing the batter would make the egg whites less fluffy, therefore there would be less batter. Overmixing would make the egg whites to be fluffier, which would make more batter, leading to more meringues.
The last issue, as you heard, was having pets in your presence. Like you saw with Arissa's cat, he knocked over the egg whites. This results to a decrease in the amount of batter.
However, to get the most product out of your recipe, you should use the exact measurements, mix the batter to the correct state, try making all of your meringues uniform in size, and avoid having pets around the kitchen.
Hello, I am Kate.
I am Anya.
I'm going to be taking a bite.
I'm going to be trying the whole thing.
This is scrumptious.
Thanks, guys. What would you rate it out of 10?
I would definitely give it a 12.
Okay, so how is it?
Delicious.
Thank you. Rate it out of 10.
Amazing. 10 out of 10. 12 out of 10.
Ooh,
10
okay.
out of 10.
Thank you so much, guys. So how is it?
It's good.
Thank you.
Rate it out of 10.
10. 11.
You hear that? Yeah.
10 out of 10.
Thank you so much.
20 out of 10.
Thank you so much, guys.
Good.
Thank you guys so much for watching.
We hope you learned something new.
Bye, Chemies. Cheers.